right, let's talk about measures of dispersion or spread. So we have something called the IQR, the interquartile range, and that is the range of the middle half of your data. So if Q3 represents the 75% of your data and Q1 represents the 25% of your data, if you take Q3 minus Q1, that'll give you the IQR, or the middle half of your data. It's more accurate if you have outliers than, say, just giving the range, but it does tell us how spread out or how far spread out our data is about the mean. Outliers are extreme values and might be cause for removal from the sample. To find the cutoff values of whether something is an outlier or not, if you want to think about it as like the lower fence, like let's say this is your data, right? And you're like, okay, I've got these as my following markers, right? Let's say I find this to be the Q1, this to be the Q3, right? If I take those values and I do Q1 minus 1.5 times the IQR, that'll give me kind of like the lowest number that I can still have without it considered, or like where it could start considered being an outlier. I can do the same thing for an upper bound where I have Q3 plus 1.5 times the IQR, and that would be my upper bound cutoff for an outlier, a data point that would just be too extreme to be considered normal for this data set, right? So if we look at the first problem that's over here, it says Mario conducted a science experiment to see how many minutes it took cups of ice to turn into water in the classroom. Okay. What was the minimum time? So the minimum is always going to be the end of the lowest whisker all the way to the furthest left. So the minimum here would be 30. What is it being measured in? Minutes? Doesn't say. Minutes. Okay. What was the maximum time? So you're going to go to the rightmost end of the whisker, and that will be 35 minutes. What was the median time? That's going to be the middle line in the box. So that would be 32.5, I guess. And then what is the IQR? That's going to be IQR equals Q3 minus Q1. So I'm going to do IQR equals Q3 is going to be this end of the box right here. It looks like it wants to be on 33. I'm going to take 33 as the upper bound. And then I'm going to look at the Q1 here. This is Q1, this is Q3, and I'm going to subtract off 32. There's 1 minute in the IQR. Okay. So the middle 50% of our data is within 32 and 33 minutes for the water or the ice to melt to water. Cool. There are other ways to measure spread of data around an expected value or the mean. The variance is going to tell us how far spread our data is from the mean. Variance gives a mean average of the squared distance from each data point. Therefore, variance will never be negative. And this poses a problem as the units of variance are not the same as units of the actual data set, right? Because whatever it is, it's like, let's say it was 3 milliliters from the center, right? And then we square it. Milliliters squared is not the unit that we were originally working in, right? So what we've created to kind of combat that issue is something called standard deviation, which is where we take the square root of the variance, and then now we have a much better idea of how spread out our data is because it is now working in the same units that we were originally working in, milliliters, right? So standard deviation is the square root of the variance. The units are the same as those of the data set. So this is like the method that we use the most to describe how spread out the data is. We use the standard deviation. So if observations are close to the mean, then the standard deviation is low, right? All the data points are gathered close to the mean. This would have a nice little spike right in the middle. If observations are farther from the mean, then the standard deviation is high. The data is very spread out from the mean. There's kind of like this low hill. Okay. Let's talk about examples. All right. So a coach has 2 basketball players who in the last 10 games have scored the following points for their team. So I have player A and then his corresponding data points, which are the number of points that he scored in the game. Player B, same idea. And then it wants us to complete the following table where we need to input the mean, the median, the range, and the standard deviation. of 2 data points. So in the past, you've learned to just type everything into one list, 1 bar stats, calculate the 1 bar stats, spit out whatever the calculator gives you. But if you have 2 data points, or if you have 2 data sets and you're trying to comment on the mean, the median, the range, standard deviation, all these 1 var stats simultaneously, you can calculate 2 var stats. And let's just call this guy the X output and this guy the Y output, and I'll show you how you can save some time. So go ahead and add a list in spreadsheet, type in your A column, type in your B column, pause the video, and then meet me back here once you have that set up in your calculator. Hello, welcome back. I thought you'd never return. Okay, so now we're going to add a calculator page, and in there you're going to go menu, 6, and instead, you're still in stat calculations, but instead of 1 variable statistics, you're going to try 2 variable statistics, okay? Your X list will be player A, your Y list will be player B, and you're just going to hit OK. So now you'll see that you not only have an X bar, but you also have a Y bar, and that's just saying like X bar is whatever you called the first list, so that would be player A. So I'm going to copy down all the information for player A with the variable X corresponding. Then I'm going to do the same thing for player B, but now with Y instead. So on the X list, it's going to look like the sum of X for player A, or it'll look like the sum of Y for player B. So let's look up the sum of X. Sum of X right here is 150. That's for total points, right? Sum all the points together. The mean, or the X bar, is going to be 15. The median, it says like median X or something like that, right? Yeah, right here. Median X is 15. The range is going to be max minus min. So let's go max X is 17 minus min X is 12. So that'll give me 5. And then standard deviation, I'm looking for standard deviation sigma X. Where is it? Right up here. 1.41. Okay, now I'm going to do the same thing but with Y. Isn't it convenient that it's already all listed out for you? You don't have to do 1 var stats 2 times. That is when 2 var stats can be convenient. Okay, so I have player B. I'm looking for sum of the Y's. Sum of the Y's, 150. The mean is going to be Y bar. He's probably up here a little bit. Where is he? Where are you at? Y bar, 15. I'm looking for median Y. He's 15. I'm looking for max Y minus min Y. So that's going to be 39 minus 0. Oh, man, he's got a huge range. Okay, 39. And then the standard deviation is sigma Y. Sigma Y. Oh, 11.4891. So 11.5. Okay. On the basis of their performances in the last 10 games, comment on which player the coach might pick in each of these 2 situations. Okay, so in situation 1, coach needs a reliable point scorer to start the game. So who's reliable, who's consistent, who has less of a range, a lower standard deviation, right? They're more consistent. He should go with player A. He has a smaller standard deviation, smaller range, same mean, so he could still produce the same kind of points over the course of a few games, but he's just more reliable and consistent. Now let's look at situation number 2. The team is down by 17 points with 10 minutes to go. Oh man, they need like a Hail Mary pass, right? If this was football, but it's not, it's basketball. But it says, who should he choose and why? I think that he should choose player B, because player B is a wild card. He scored 39. The range was wild when I calculated the range. He scored 39 points in his range. That's wild. This standard deviation is greater, and the range is greater. He's our wild card. We should go with player B if we're down and we need some help. Okay, now let's talk about example number 4. A data set consisting of 16 test scores has a mean of 14.5. One test score of 9 requires a second marking and is removed from the data set. Find the mean of the remaining 15 test scores. All right, so we start with 16 test scores, right? And we are given, it's just one bar, we are given a mean of 14.5. So I don't know what the test scores were, but I know that the sum of all the test scores divided by 16 is equal to 14.5. Okay, so I'm going to just multiply these two. I'm going to kind of cross multiply and get the sum of the x's is equal to 232. Okay, so that was with the old scores. Now, one test score of 9 requires a second marking and is removed from the data set. So we have the original sum, and then we subtracted off that 9 score. Now there's only 15 data points, and this is going to give me my new mean. Oh, I have this right over here. Perfect. Okay, so I have 232 minus 9 divided by 15, and that will give me 14.8667. The new mean is 14.9. All right, and last but not least, it says the number of hours spent exercising each week by a group of students is shown in the following table. The median is 4.5 hours. Okay, so that's my little clue, right? So the median is going to happen right here, because these are the like exercising time. These are the data points, right? Think I've got like 5 twos, 5 people who work out 2 hours, 1 person who works out 3 hours, 4 people that work out 4 hours, right? This is what's happening. So 4.5 is going to be my median data point, okay? So I got to think about how many data points there are above 4.5. There's 10. So that means if the median is 4.5, there's got to be 10 down here, right? That means that if I have x plus 3, he must equal 10. X must be 7. Now I have to find the standard deviation. Ooh. What I'm going to want to do here is do one var stats. That way I can calculate the standard deviation, okay? So I'm going to add a list in a spreadsheet. Do I have an x in here? I don't think so. Nope, I don't. Okay, cool. So now I'm going to put in x, and then this will be my frequency. Okay, so x is 2, 3, 4, 5, 6. And then my frequency is 5, 1, 4, 3. And now I know what x is. X is 7. So now I'm going to calculate one var stats for this guy. Menu 6, 1, 1. And my x list is x. My frequency is my freak. Boop. And then I've got a standard deviation of 1.58.